Kia ora koutou, welcome to this next video on energy changes. In this video we'll look at the energy changes associated with the changes of state of a substance. So if we had a substance that was a solid, we know that when substances are in their solid state, the bonds between the particles within the substance are strong, and so these particles are not able to flow past each other and they hold their rigid shape. So solids have got strong bonds between the particles. And then if we move this into a liquid state, the bonds between the particles are not as strong. So the particles are able to move past each other, although there is still uh, some some bonds there. So if we were to pretend that this was a substance, if this was water, so we've got an ice section of ice here, and we have melted the ice. What would we do in order to melt ice from the state where the particles are held really strongly together to where they're able to loosely flow over each other? Well, we know that we would need to input some heat into the system. So if we were to um, take our ice out of the freezer and put it on the bench for a while, the ice would end up melting because there would be enough temperature around it where the ice would absorb the heat and we would turn into a liquid. So with what we've learned in the last video, we can now describe that as a reaction that has absorbed heat. So we know that if we go from a solid to a liquid, we are actually, so we're breaking these bonds slightly, we're weakening these bonds, and that is an endothermic reaction. So we know that reactions that involve heat energy being absorbed are endothermic reactions. And then conversely, if we were to take that water and put it back in the freezer, I'm just going to make this arrow a little bit easier to understand. So we've got this reaction going this way. That's endothermic, so that's breaking the bonds and it requires the input of heat energy. If we then go from a liquid to a solid, we could put the water back in the freezer, and what's actually happening is that energy will be released. So we've got an exothermic reaction. So energy will be released into the freezer, but there's the constant cooling of the freezer, so that's able to cool down the liquid until the point where it's a solid. And so that's what we're talking about when we're talking about the energy changes and the changes of state, is that if we weaken the bonds by changing the state of a substance, then that is an endothermic reaction because it requires the input of energy. Whereas if we strengthen the bonds, for example, going from a liquid to a solid, then that is an exothermic reaction where heat energy will be released into the surroundings. So we can visualize this slightly differently with a triangle here. So we can go from let's just think of all of the different changes of state that would involve the strengthening of bonds. So if we were to strengthen a bond, we could go from a liquid to a gas. So, sorry, from a gas to a liquid. So that's where there's no bonds at all between the particles and the gas. And then if we were to reduce the heat enough um, so that those particles came together and able to bond together slightly, we would get a liquid. So that would be because those bonds are strengthening. When bonds are strengthening, we are releasing energy. So this would be an exothermic reaction to go from a gas to a liquid. And then same again if we were to go from a liquid to a solid, we are what we've just seen before, we are strengthening the bonds between the particles. So that's an exothermic reaction as well, with heat energy being released. And then from a gas to a solid, I had to look this up, what the word is because I don't use it very often, but deposition from a gas straight to a solid where the liquid phase is skipped out. That is also the strengthening of bonds. So that would be an exothermic reaction. So these are the changes of state that would go about for an exothermic reaction. If we were to weaken bonds, that would be an endothermic reaction. So going from a solid to a liquid is weakening bonds. So there's an endothermic reaction in that change of state. If we were to go from a liquid to a gas, that again is weakening the bonds. So that is an endothermic reaction as well, where heat is absorbed. And then for sublimation, if we went straight from a solid to a gas, then that would be absorbing energy as well. So that is an endothermic reaction. So we can write the general phrase that we can use is that the breaking of bonds, breaking or weakening in the case of going from a solid to a liquid, of bonds requires, breaking of bonds requires energy, the input of energy, so it's endothermic. And the making of bonds, or strengthening we could say, of bonds releases energy. So that is exothermic. So this kind of question comes up where we need to give a descriptive answer in exams. So last year's exam had the question, ice H2O solid is placed in into drinks. As the ice melts, the drink cools. That's something we intuitively know. So we've got, excuse me, what's going on? Here we go. So we've got H2O in its solid form going into H2O in its liquid form. We can see that the change in enthalpy of the reaction is positive. So if you see a positive number, that means energy has been released into the surroundings. Sorry, it doesn't. It means energy has been absorbed as the reaction takes place. So use your knowledge of enthalpy changes associated with changes of state, which is what we've been looking at, to elaborate on the reason why the drink cools. So to answer this question, we would talk about the bonds that are strengthening or weakening in this reaction. So we're going from a solid where there are strong bonds between the H2O particles to a liquid where the bonds are weakening. So we would say that the weakening of bonds, or the breaking of bonds is an endothermic reaction, or we could say process. This means, so we're going to explain what endothermic means. So we're showing to the examiner that we're not just using catchphrases where we know what we're talking about. So this means that energy is being absorbed from the surroundings. So the surroundings in this case is the rest of the water. So we've got the ice is absorbing energy from the water within the cup. So this reduces the temperature of the water in the glass. And that would show that we know what we're talking about with the endothermic reaction. So we'll just check our answer by going onto the NZQA website and then having a look at the 2019 assessment schedule. So the melting of ice is endothermic as intermolecular bonds are being broken as water changes from solid to liquid. This requires energy to be absorbed from the surroundings. This causes the temperature of the drink to decrease. So I'm pretty happy with that answer. We've done pretty well. So that is the energy changes related to the changes of state. We've got two more videos that we'll look at. The next one is specifically looking at the making and breaking of chemical bonds. So this is more intermolecular, intramolecular bonds, so covalent bonds. And then the next video we'll look at after that is being able to calculate the change in energy if we were given a known mass of a substance. So thanks very much for watching this video. Like and subscribe for more chemistry videos. See you next time.